Alright, let's just do a quick audio test. Make sure you guys can hear me okay. You guys can hear me? Yep. Alright, awesome. So, tonight, originally, we had something a bit different scheduled. We had originally had... Let me go to the syllabus. I think it might have been, parent-child relationships. So we're still going to do parent-child relationships. However, it's going to be... Well, actually, I think we're okay, because we have including files and normalizing paths, which we're not doing. So we would have been in parent-child relationships, then authentication. How many weeks do we have left, out of curiosity? Let's see here. So today's the 22nd, the 29th, and the 5th. So tonight, and then 1, 2, 3 weeks, because you guys are done on that week. So 3 weeks, and technically the 5th is Easter, so I'm not sure how that's going to affect us actually. So we have 3 weeks. So we're not doing this one. We're not doing this one. We have these two, and then reading files. So actually, what's likely going to happen, based on the fact that we're still working on kind of a condensed load here, we're going to cover parent-child relationships under authentication. And then if we get to working with files, we do. If we don't, we don't. It doesn't matter, because this is not nearly as important as these two are. These two are much more important. Working with files is like 2 seconds of your life. Authentication is something you're going to be doing all the time. So it definitely makes more sense. So tonight's lesson is actually partly due to the fact that I took over Jessica Gilfillan's class. So now, in order to kind of limit my workload a bit, instead of doing like a lesson for her class and then a lesson that's different for my class, I'm just going to adopt what she's doing for her lesson, because when I took over the class and she gave me her course material, she has slide decks, but she doesn't have examples anyways. So I thought, you know what, if I'm already writing the example, I'll just use it. And then next week, they're on the same par as you guys. They're doing authentication, so you guys will be doing authentication as well. And then everything is nicely lined up, and then it's not crazy for me to figure out at the end of it. So that's the goal. The goal is that. All right, so APIs, right? You guys have heard of the term APIs, I'm assuming. Oh, before we do that, we should recap. I mean, getting ahead of myself here. Let's recap what we actually talked about last week. So last week we looked at including files inside files and dealing with the kind of craziness that comes around that with dealing with nested files, right? Because nested files gets things very complicated. Mostly due to the fact that you have files referencing files from other locations, but all references come from the executing file, right? So if you have a file under your root folder, and yet you have files nested upon nested, and they're all including each other, it's translating those file paths from the root directory, because that's where the executing file is. So in order to fix that, we took a look at normalizing and linking path routes so that we can actually normalize where the reference is coming from. That way we can always guarantee that the reference is coming from the same location. That way it's much easier to include files, and we don't have to worry about the executing files location, because that's irrelevant to us at that point. So it's quite intricate how it works, and we took a look in depth, and I do recommend studying this, especially if you plan on working with PHP a lot. We're going to kind of abandon it this week, but we will be getting into it more so next week when we take a look at authentication, because we're going to build out a whole application, and the application is going to have required files. We will be using it a little bit tonight, but we just won't be creating that config file, that's all. So that was basically what we were covering last week. I was going to do a quiz for tonight, but there's no quiz for this particular class on Jess's side either, so I'm not going to do the quiz tonight. However, next week will be a quiz and a lab, all in one kablammy. So just keep that in mind, that you will have 2 things for next week. No things this week, 2 things next week. All right. Let's talk about APIs. Now, I do have Jess's slide deck here. I'm not going to go over all this stuff. We're not going to do week 8. We just did our week 8. We are going to talk about what an API is, about building an API, and then looking at integrating a third-party API. In here, she has Google reCAPTCHA. However, Google reCAPTCHA requires you to have a Google account. Then we have to register an app with the Google account. We have to set up all the details with that, and then apply that to our application. And then when we go live, if we decide to go live and put it up on the internet, we have to re-register a new URL with that. So it's just a little much to deal with. What about other labs? We're going to cover that too. Yeah, so there'll be 2 labs back to back. How many labs have we had? 1 or 2? I forget. Yeah, we've had 2. So I think we only have 1 left, don't we? If I look at the syllabus, I think there's only 1 lab and then 1 quiz. There's only like 5 things altogether. Is there 5 labs? Oh god, there is 5 labs and 4 quizzes. I didn't realize that. I thought I had broken it down the same way that I broke it down with the other course. Yeah, that's crazy. I didn't realize there was 5 labs. If that's the case, well, I know with Jess's, there's a lab in this one, a lab in this one, and a lab in the 3rd class as well. So what we will do is we will have 3 back-to-back labs and 3 back-to-back quizzes. So yeah, it'll be literally a lab and a quiz every week from here on in. But they'll be very small and self-contained, or at least I hope they are. I haven't actually looked at her labs to see what they are, but I will likely edit them if they're not. So yeah, we'll have 3 labs, 3 quizzes starting next week, which is a little much, but yeah, that's what we're going to do. All right, so integrating third-party API. We're not using Google reCAPTCHA just because of how annoying it is to actually connect it up and get it working. It's just a little much, and I don't feel like troubleshooting issues like that. Instead, we're going to use the Chuck Norris API, which is still a third-party API that we're going to connect to and work with, so you still get that experience of working with it. So either way, I mean, both are basically the same thing anyways. All right. These are resource links that you're welcome to look at. These are things that Jess has identified as being kind of like cool little things to know. They are fairly interesting, so it's worthwhile taking a look at them, but you can do that on your own. So week 8 review, we already talked about it. Just skip past this. They actually didn't even do this last week. This wasn't what they did. Sanitizing and normalizing user data. What did they do? Or maybe they did. Actually, yes, they did. They did form validation. I have way too many classes on the go now. 4 classes is what I'm working with, and they're all at different points. So I'm trying to get everybody in the same point, so it's a little easier to manage. All right, APIs. What, how, and why? What is an API? Can anybody tell me what what API actually stands for? Does anybody know what API stands for? No? Yes, actually, yes, exactly. Application programming interface. So the idea of an application programming interface, you guys have worked with APIs without likely even realizing that you're working with them. So when you're accessing a library, right, that is a part of the core program, like part of the core programming language that you're working with, you are technically interacting with an API. It is providing you an interface into working with commands and library components of that application, of that programming language, that through a nice safe interface, right? So for example, the JavaScript math API that's built into JavaScript that allows you to be able to perform math operations like rounding or seal, right? For like ceiling or floor. What else do they have? They have .product. They have POW for powers, all those type of things. They're all like nice little programming interfaces for you to use in order to perform operations using the math API. They also have other APIs like the fetch API that's built into JavaScript as well, which allows you to be able to fetch, other resources, external resources, and bring them into your application. PHP has a bunch of APIs built into it, not only for dealing with like files, because they have a whole file system API for you to interact with files. They also have, I can never remember the name of it. It's not ImageMagick, it's built on ImageMagick. I want to say it's the GD library. I think it might be GD, but it's like a graphical library, and it's an API as well that basically creates an interface for you to work with the ImageMagick library, but through a nice, friendly PHP way, right? So that's also an API. However, when we talk about APIs, a lot of people don't think of APIs in that way. People think of APIs as an external thing that we're accessing, right? Some sort of program somewhere else that we're going to interface with. So how does that work exactly? So you can think of an API at being an external resource, right? It's an external resource that provides you various little points of access, little gateways, right? That you can go through in order to access certain types of information. It controls how you access that information. So you get these endpoints, you send requests to these endpoints, and the endpoints return back information to you, but you can only access the information that they allow you to access. They control that. You can also perform operations, like, so for example, I had a student in my JavaScript class use the, what's it called? The card shuffle API, which is basically allows you to create a deck of cards, and then you can use API endpoints to deal cards, and it keeps track of all that information, like what cards are still in the deck, what player has what set of cards, that type of stuff. But it's all an API. You just keep accessing the endpoints and keep grabbing what you need from it, and then you give it a little bit of information so it can update the deck. API is super handy, super handy. Understanding how to build an API is very important as well. Have any of you ever actually worked with an API before this class? Have you ever reached out to an external API and accessed information? No? So some people have by using like Google Maps. Like you might have implemented a Google Map into your some sort of website that you were building. That would be accessing an API. Right? Google reCAPTCHA is another form of APIs, right? There's a whole bunch of different types of them. So what is an API? An API is something that is made available in programming languages to help developers create complex functionality more easily. I would even add to that and say an API is something that has been built into an application to allow you to access functionality or data in an easier method. Is a Java interface considered an API? So correct me if I'm wrong, it's been a little while since I've done any OOP, but isn't an interface essentially a blueprint for a class? So an interface describes what a class is supposed to have, like what methods and properties a class should contain, and then you build your class by inheriting that interface? That's what I thought. So no, then it's not. So an API is, think of an API like a simplified method to access a more complex method. So you can kind of think of like PDO, PDO that we've been using to connect to our database. PDO would be considered an API because PDO abstracts the whole idea of having to create a MySQL protocol in order to access the endpoint from the database, setting up all that transfer protocol, the correct headers, all the information you require in order to access the MySQL database. It abstracts all of that so that you don't have to see that. You simply give it the database path, the username and password, and then everything else underneath the hood, PDO takes care of that for you. PDO is an API. Essentially, it's something that exposes simplified methods to access more complex processes. That's really what it is. Yeah, no worries. It's a way to abstract more complex code and provide easier code. That is true as well. So how do APIs work? Well, they're based on objects, kinda. Have recognizable entry points. Yeah, that's definitely something that they do. Use events to handle changes in state. Yes, they can. And additional security mechanisms where appropriate. Essentially, APIs basically provide you a front interface to accessing complex functions. That's basically it. They provide you a simple way to access complex functions. Building a simple API and adding Google reCAPTCHA. Okay, so that's what we're going to get into. So I kind of created a very interesting... I actually had a fun weekend because I've never actually built an API in Java or in PHP before. No, that's not entirely true. I've built a very complex model view controller system in PHP, but I've never built a simple API in PHP. So it was kind of tricky because I wanted to make sure it was a way that I wanted to build it in a way that I could pass it on to you and you guys would grasp what was happening without needing to understand a whole bunch of other types of data architectures and computer science. So this is a very simple API that we're going to build, but it is still pretty cool, and I hope you guys will apply this to other things. This is definitely something I would share as part of your portfolio when you're done, because this is not something that your competitors in the industry are likely going to be doing. Okay, just keep that in mind. Now that I looked at Jess's slide deck, I don't even think it's what she was intending. Now that I think of it, I think what she was expecting to do is just build a small function library locally and do that. So I definitely went overboard. But you know what? We all like learning, right? We're all like programming. Hopefully you like programming. Otherwise, why are you in a programming class? All right, so let's click on the starter files here, and we'll bring these guys down. And those are obviously going to go to our downloads directory, right? So we're going to need to extract those. So I'm going to right-click, choose to extract all. I'll just extract it into this API example student directory. And then I'm going to double-click on it. And there's my 2 folders that I need. Okay. In my other File Explorer window, I'm going to navigate to where we've been storing our lessons. So WAMP64, the www directory, 1006, and I'm going to create a new directory in here called lesson-07. I'm going to drill into that lesson, and I'm going to drag over these 2 directories and put them into there. So I have my API and my client directory. I'll explain what those are in one moment. Once we get everything kind of up and running, I'll explain what those are. Next thing I'm going to do, I'm going to right click on this folder so that I have both of the folders, and I'm going to click open with code, and I'm going to attempt to drag this, there we go, over like so. So now I have my API directory and my client directory open in my code editor. And then I'm going to open up WAMP. And let it go green. And we're good to go. So my next step obviously is to navigate to that lesson. So localhost /comp-1006 and the lesson 7 directory. And the folder that we're going to start in is the client folder here. So I'm going to click on the client folder and that will open up. And I'm going to zoom out a little bit. So the client is already kind of created for you. Your WAMP is not working. What does that mean exactly? Is it not going green? Is it red? Is it giving you an error? What do you mean by your WAMP is not working? The configuration file contains a syntax error. Is that when you navigated to this website, or is that just as you were starting it up? Oh, in the Aztan tray menu, I think we can... There's a way to reinstall all the services. Does anybody remember how to do that? Is it under Tools? Oh, right. If you right-click on the little WAMP symbol, Gurleen, and click Reinstall All Services, it will reinstall them all with the correct configuration as well. Oh, you're not even getting as far as the WAMP symbol? Try restarting your computer. You might have, like, I don't know, some WAMP process that's died in the background somewhere and it's causing errors. So just restart your computer. Okay. We'll wait for you. While we're waiting for Gurleen, I've created the client for you. We actually have these two pieces separated on purpose. Generally, when you start working in the industry, a lot of the industry is gone with creating a client-side version of their code and then a server-side version, right? So you guys have done that up to this point. We've created server-side logic that renders the client. So we essentially send basically a view, right, that we create. We create all the HTML, we embed all the PHP, and then we send that full rendered information to the browser. And then the browser renders it, and we get our view. However, a good chunk of the industry works by separating those two pieces. So we have a piece called the client, right? And the client is just front-end code. That's all it is. It's just stuff that we render in the browser. It can exist anywhere. It can be on any machine, anywhere in the world. It could be on a phone. It could be on a tablet. It can be anywhere in the world. Doesn't matter. And then all of our data that we interact with is stored in an API on a completely other machine. So it might exist on a computer in AWS or in Google Cloud or in Azure. And then in order to get information to write to it, read from it, or update or delete, what we do is we send requests over the internet to this server, to this API server, to facilitate those requests. And the way we do that is in our API, we expose these things called endpoints. And what endpoints are is they're just a URL in your browser, basically, just a simple URL that we send a packet of information to, and then it processes that packet of information. So tonight, what we're going to do is actually build the API and then use the client that I'm providing you to communicate with the API. It's still not working. I don't know what to suggest short of uninstalling and reinstalling. Okay. You have lots of errors on the client page, Marcos? They're probably all database errors. Are they database errors? Yeah. 1006 lesson 9 client index.php. Yep. No, that makes sense. Totally makes sense why you're getting those errors. So let's fix that actually. In our client, I'm just going to shrink this window down a bit over here. There we go. In our client, in the index.php, open up this page. So right now, the issue that we're going to have is that this base endpoint that I've actually published in here is supposed to point to this API file, and for me, it is. For me, there's no issues right now. It seems to be pointing just fine. Actually, it should be failing. Should be lots of errors in here, because that should be totally failing. And for whatever reason, it's not. Oh, I think it's because I actually have this. I have this directory. That's why. So if I break this, if I was to just get rid of this link altogether and save it and then refresh, I'm getting the same errors you guys are getting, right? Essentially what it is, I need to give it a valid endpoint, okay? And the valid endpoint that we're going to give it will be this endpoint here, this API endpoint. So what I would like you to do is just click up inside your browser, hit Control-C on that URL and paste it inside there, and change the word client to API, like so. So you're clicking up in the address bar, highlighting that text, copying it, pasting it into your base endpoint variable, and changing the /client to /API, like so. And then when you refresh, most of the errors should go away. Yep. So now what's happening is our base endpoint is pointing to our actual API folder, which is what we want. Okay? So the part of the issues is that we're trying to access the rows from our contacts API endpoint, right? And it's saying, so it's using this base API endpoint and it's accessing contacts. But the problem is that is broken right now. That URL does not exist. So what's happening is it's accessing it, but then we're winding up with errors, right? On line 90, for example, it's saying this value doesn't exist, and that actually makes sense because we're not pulling that error. So if we want to fix this, we're actually going to have to fix our API. That's the problem. Because our API is pointing to these things, but the data we're expecting to come back is not what's coming back, unfortunately. We are getting different data back. Okay. So let's go see what we can do to fix a lot of our problems. The first thing we need to do is actually work on our API itself. These requests that we're sending are based on a pattern, right? We're following a pattern. This base endpoint just points to this API folder. That's all it's doing. This would be the equivalence to you pointing to an API endpoint somewhere else, like Google or our Chuck Norris API that we're going to work with tonight. Any type of API. You're pointing to the base. So that just gets you in the door. That's all it's doing. It's just getting you in the door. You haven't actually requested anything specific yet. We want to request something specific. So if you scroll down a bit, you'll notice that we have some of these patterns kind of showing up. Like the first one, for example, for accessing the rows from our contacts API endpoint. So in here, we have our base endpoint / contacts. Contacts is a resource that we want to access. So what actually is getting produced inside this path is HTTP localhost comp-1006 API / contacts. When we make a request, that's what file get contents is doing, it makes a request to an external endpoint. Our external just happens to be internal. So this is making a request to the /API folder. That's going to come into here. And you might be like, oh, okay, I see. So it's in here. That's this part here, right? And then it's accessing this contacts directory, but there's no index file in there. So that's probably why we're breaking up. But it's not. This thing gets a little bit more complex than that, but with reason. What we want to do is be able to read this value, okay? And then understand what it is that they're trying to access. So this is a resource, and we want to access the contacts resource. So we need to create that inside our API. So before we do that, what we're going to do first is build something to interpret those paths. A lot of the paths the user is going to type in are going to connect to various application endpoints that we allow them to access. Our API is just facilitating taking that path that they've requested inside their browser and translating it into a function so that we can pass back data that they're requesting. So our basic path is API. That's our base point. That leads us into this directory here and accesses this index.php. If a user wants to access all of the contacts that we have in our database, we need to give them an endpoint that they can access, and then we will run the queries that we need to run, grab all the contacts, and send them back to our user. So the path that we will let them do that on is API/contacts. So if they were to access this endpoint, we will return all of the contacts inside our database to them. If they want to access a specific contact, we need to give them an endpoint for them to be able to access one specific contact. So we will make it API/contacts/show, and then we'll let them pass us an ID so that we can grab that specific contact for them and return them, right? So we'll just say ID. We'll use :ID like a placeholder, almost like a bound parameter. If they want to create a contact, we need to give them some way to be able to create it. So for that, we'll let them post a request to /contacts/create. So if they post a form, so they fill out this form, for example, and click create, we will send that post request to this endpoint, and then we will create a new contact using the information that they provided us. For updating a contact, same kind of idea, only they're going to post that to /API/contacts/update. And then for deleting a contact, we'll collect that from /API/contacts/delete. And all of these three will be post requests done through the form. And then we'll just make sure that we pass an ID so that we can go ahead and figure out who they're trying to update or who they're trying to delete. The problem is that the internet, the basic internet for Apache servers don't work like this, right? If I was to pass this to through my browser right now, for example, so right now we're pointing there, I'm going to go to API/contacts, right? If I do that, it loads up and I see controller.php, right? The reason that's happening is because our server doesn't know that we want to go through this index page. It just automatically follows the paths. It's like, okay, cool. So you're in lesson 7. Yep, I'm in directory lesson 7. I'm now accessing the folder API. Cool, I'm accessing the folder API. And now I'm accessing the folder contacts. If I wanted this page to load up automatically when I go there, I would have to provide an index.php page in here for that to happen. But what's kind of neat about Apache servers is they allow us to create a configuration file to kind of hijack that and turn this into a bit of a different operation. And the access file that we use for doing that is called an htaccess file. Have you guys manipulated an htaccess file before this day? Or ever touched an htaccess file before this class? Nope. Cool. So what an htaccess file does is essentially tells Apache, the web server that we're working with is called Apache. It tells Apache how to handle a request. So this request comes into Apache, and generally what Apache does is it goes and finds the file that you're looking for, renders it through the PHP binary, and then returns it back to the client. What the htaccess file will do is say, hold on, stop. Let me take a look at that request for a second. Yep, it meets these rules, so now we're going to do this with it instead. So let's open up our htaccess file. This is the first file we're going to edit inside our application. So what essentially we're doing right now is creating something called a router, or we're actually facilitating the thing that's needed for our routing to work. What a router does is it looks at a URL, like so this URL that you see here, it looks at the URL and tries to establish what function you want to call. But in order to do that, we need to make it so that contacts, when we go there, doesn't go to the contacts directory, but instead goes to this index.php. We want to make all requests that go to the API, regardless of whatever is at the end of this, whatever at the end, whatever is at the end of this all goes to the index.php file. Every single request we make. And that's simply done by writing this little chunk of code here. So if module, and I will share this, mod rewrite.c, and we close that with an if module. We want to turn the rewrite engine on. And we want to define a rewrite rule. Essentially what this says is if the mod rewrite module exists in Apache, which for every basic Apache server that's created through XAMPP or WAMP or MAMP should already be turned on, then we want to turn on the rewrite engine. What the rewrite engine does is it actually rewrites this URL that you see here so that it's nice and it looks like this, right? It doesn't automatically add index.php to the end of it. It actually rewrites this whole thing. The next rule that you're looking at here essentially redirects it. So this is a little chunk of regular expression. Basically what it says is if this path matches this code, which it will, automatically it will, because this is a wildcard saying literally everything. Every single thing. If this path matches this little chunk of code, which it does, redirect it to the index.php page. That's essentially what this code says. I don't expect you to remember this. This is not going to be on a test. Just all I want you to be aware of is this is the thing that's going to stop our page from automatically going to the contacts directory and make all requests to the API hit our index.php page, which is what we want to happen. So if I refresh, notice it went blank. And it went blank because now it's all going to this index.php page. Every single request we make is going to hit the index.php page. So I realize that seems like magic and maybe a bit above your head, but rewrite rules and actually working with rewrite rules in htaccess files is a very, very common thing that junior developers are expected to be able to do. And they're given this task often. I know we do that too. We write tasks for redirects because what happens is somebody changes a URL somewhere in our system, and then we have to go write redirects for it because we have advertising and campaigns and all this other stuff out there that is referencing the old URL. So we need to redirect the old URL to the new URL. And that is done through htaccess files using this type of pattern. Sometimes it's not htaccess files, sometimes it's a different type of configuration file, but essentially this logic is roughly the same. Does that make sense? Do you have any questions? No? All right. So just one quick last explanation just to see if we can get it over the edge. When we go to /API and hit enter, we are accessing this index file by default. We can even navigate to it directly, index.php. We're accessing this index.php by default. Essentially what happens is Apache, when you go to a directory and you haven't stated what file you're going to, it will automatically load the index.php. But what we've done with our rewrite rule, if I go to, say I go to contacts/controller.php and hit enter, I'm actually not hitting this controller file. I'm still hitting the index.php file. And I can demonstrate that. Let's just var dump something out. Booyah. There we go. And as you can see, Booyah loads up, right? If I go to contacts is my favorite place. That doesn't exist. I don't have those folders in here at all. And I hit enter, it still goes to Booyah. This htaccess file is funneling anything that goes to our API to the index.php page. Doesn't matter what it is. Everything gets sent to this page. And that is super, super important for us because we need that in order to decipher. We're going to use the user's path to figure out what they're trying to request. So if they're requesting contacts, for example, I'm going to be able to read that and be able to tell what they're requesting from me. Pretty cool, eh? Like I said, though, this is a very simple API. This is not how routing is generally done. It's much more elaborate, but we're doing it extremely simple so that you understand the basics of what is happening. So the first thing we need in order to process the request, right? So the user has sent this request to /contacts, and they want obviously the contacts. That's what they're looking for, right? They don't want Booyah, they want contacts. So the first thing we're going to need to do is to create a simple function for sending back a response in a specific format. Generally, APIs usually send the response back in JSON format. The reason why we use JSON as a format to send it back is because a lot of applications, a lot of programming languages can understand JSON. They have some way to convert the JSON into some sort of format that they basically understand. That's not just PHP and JavaScript. That's literally every programming language I've ever worked with, and I've worked with like 9 different programming languages. So like Go, for example, Python, Ruby, PHP, JavaScript. What's the other one I'm thinking of? C#, C++, right? All of those work with it. And I'm forgetting one. There's another one that does too. They all work with JSON. So JSON stands for JavaScript Object Notation. And essentially all it is it's known as self-describing data. Basically, it's a structure that describes what is happening inside the structure. So we've kind of built little pieces of this without realizing it. So we've worked with associative arrays. Remember when we talked about associative arrays? That structure of the associative array is essentially the same kind of structure of what we're building with JSON. Let me show you quickly what a JSON would look like. So JSON has property names, right? So you can have whatever kind of property you want. So for example, name is Sean. These curly braces denote that this is an object. That's what they stand for. I can say my age is 42. And I could give myself hobbies, right? Diablo and movies. There we go, right? If I was to write this same structure in PHP, we would write it like so. So the structure looks the same. The good news is, though, is it doesn't matter what the structure looks like. When we produce it in PHP, we're going to use PHP JSON encoding methods, so you won't ever see this. You will only ever see this. So it doesn't matter. That's why I'm not getting into a big lesson on what JSON is, because there's just no point, because you don't even work with it that way. So the first thing we're going to do is build a response function that we're literally going to respond to all requests with. This function we'll use throughout our application, and because we're defining it at the index.php, and the index.php is always the executing script, this function is available throughout our entire application, regardless of where we are. So the first thing I'm going to do is set a response header. So we're going to give it 2 parameters, one for code, that's your status code, and the second one is the message you want to send. Then we're going to set an HTTP response code, and we'll pass code in there. So whenever we send a request, there's always an HTTP status code that comes with our request. can show you that under the network tab. If I hit refresh, see these statuses, 200, 200, 200, 200. These are our HTTP status codes. They tell the browser that everything was okay. 200s are okay, 300s are redirects, 400s are bad, 500s are really bad. The next thing is we define what type of content type we want to send back. So we're going to set a header. We've used this for location, but you can actually use it for a lot of different things. And we are going to send back our response always as JSON. And then the last thing we're going to do is encode our message so that it is an encoded JSON response. So it's a simple function to respond with correct headers and a status code, and will convert all responses into JSON for us. Okay? Still with me? So HTTP response code sets the response HTTP code. 200s are good. 300s are redirects, which is unimportant to us right now. 400s are bad. Those tend to be ones that you fire off. So this resource doesn't exist, so it's a 404. You've access to forbidden points, so we send back a 403 forbidden. Unavailable, so a 401. 500s are really bad because 500s are server errors, meaning that we've encountered an actual server error, which is not necessarily an error you've created, it's an error that's happening with your code. It's usually a logic error. All right. So we have our HT access. We have our function. The next thing we need to do is to create our connect function. Now I think I already created it for you. Yes, I did. The only difference between this connect function and any one we've called before is that I've wrapped it in a function call. The function call means that instead of having to remember that my database name is $DB, I just simply call DBO and call it as a function call. So that's what we'll be doing. We'll be, anytime we need to connect and work with our database, we'll be calling DBO. So the connect function will be available to any of our subsequent included files. So any file that gets included, this means that to interact with our connection, we simply call DBO anywhere. Step 2, a RESTful API, which is essentially what we're building, requires us to be able to understand the request path provided. So this is our request path, right? Our request path is API/contacts. This is the actual part of the request that we care about, the contacts part. As it will determine the key parts needed to build the proper response. So we need to be able to extract the information from that in order to build out what we want. So there's a few different pieces to this to create it. We'll write it out first and then I'll explain what it is. So we're going to create a variable called resolved path. And what the purpose of the resolved path is going to extract the important pieces of information from the path that the person typed inside their browser. So we're going to use string replace here. Okay. And we're going to access a few pieces of information, but before we do that, I want to show you what those information pieces are. What the heck is happening? I'm typing in characters that I'm not meaning to. There. So remember a while ago when we talked about associative arrays, we took a look at a few of them, right? We looked at the post one, we looked at the get one, right? And we looked a little bit at server. We outputted it on the screen, but that was it. Let's take a look at two very specific parts of the server, and we'll var dump them. So we're going to look at server/php self, as well as server request URI. So the first one, you guys may have used this in our forms. I can't remember. I think we did on day 1. We used this in a form. When you have this in a form, essentially what it does is it returns back the path of the executing file that it's called in. So our executing file is index.php. So it's returning back the path that this file is being executed in. So comp 1006, lesson 7, yep. API, yep. Index.php. That's what we're returning. The $_server request URI will return back the requested path. So as you can see, this is the requested path inside our URL. That's what it's returning back, is the requested path in the URL. What our function is going to do down here is it's going to create an intersection. It's going to, we're going to get rid of this index.php part, and we can do that, we can do that by prefacing this with dir name and pass that as an argument. And what that will do is only return back the directory and not the file name as well. So now, as you can see, we get this part. What we want to do is basically replace this part of the requested path with an empty string, so that the only part we get back is the little chunk at the end that they're requesting. That's it. So I'll comment that out. I will uncomment this, and that's exactly what we're going to type in here. We're going to type in dir name, and in that we're going to put $server php self. Then we have to give it the thing we want to replace it with. So we're just going to replace it with an empty string. And then the third argument is where we're looking up to replace the thing that we're replacing inside of, which is this path here. Whoops. I thought I selected it, but I don't think I did. So once again, string replace replaces a needle with whatever you tell it to replace it with within a haystack. The needle is this chunk here, which is exactly what you see right in here. We're looking for this. When we find it, we're going to replace it with an empty string, and we're looking for it inside this haystack. That's how that works. So what we'll get back, can anybody tell me what this will return? What will string replace return? What will be the value of resolved path after we put that in there? Does anybody know? What will be the value of resolved path? So this is our needle, this is our haystack, and we're replacing it with an empty string. Yes, pow, exactly. /contacts is exactly what we're going to wind up with, because this part here is going to get removed when this gets replaced, and we'll be left with contacts. No space though, Marcus. That's an empty string without a space in the middle. So that's cool. We have our resolved path. So now what are we going to do with it, right? So we're going to need some parts, and we have a few different pieces. What we want to do is take the remaining part of this and break it into chunks that mean things, right? That have certain meanings. So the easiest way to break it into chunks is by using the explode function built into PHP. What explode does is it takes a string and explodes it by a delimiter. So you give it a delimiter, and then it explodes it into an array of values based on that delimiter. So we're going to say explode, give it the delimiter, which will use the slash. So this slash you see here. If you're on a Mac, you may have to reserve that, like reverse that slash. And then the thing we want to explode, which is our resolved path. So that's what we're going to explode, is our resolved path. So if I var dump this and the parts, you can see what this is doing. So it returned back our slash contacts, right? So after we performed our intersection, we wound up with resolved path, and resolved path is slash contacts. When we exploded it, we get an empty string, which is the first slash, right? This first slash here. Then we get the value contacts as our second piece of information, and then an empty string for the last piece of information. So it gets exploded into 3 parts. And that's predictable. I knew that that's what was going to happen. And I know exactly what order those parts are in. And this would be true for any API, because you would dictate how the person actually makes requests using the API. So the first part will be the root. So we'll reference it just using 0. Parts 0. So this is the index number, and we're accessing that section of parts. If you forget how that works, you need to go all the way back to lesson 1 when we talked about arrays. $resource, this is the resource I want to access, will be under parts 1. Can anybody tell me what value resource will be? What would be the value of resource? Looking at my browser, you should be able to determine it. Yeah, exactly, contacts. So the thing we're accessing will be contacts. That's what we want. That's our resource. When I use the term resource, resources always are a one-to-one relationship for me to a table in the database. That's what I consider a resource, or any data really. Any data that I want to access, I call a resource. The next one will be an action, and that will be under parts 2. Now that will be just an empty string at this particular point. And then the remaining parts, if there were any, there isn't, but if there were any remaining parts, I want to store them under my params, which means that would be literally all the leftover pieces of the array, right? If there were any other pieces, like say this was like Gerald loves dogs, right? And I hit enter. As you can see, there's a lot more pieces to this now, right? I have contacts, I have Gerald, and I have loves, and I have dogs. Well, contacts would be the resource. Gerald would be the what? What would Gerald be? It's not the root, and it's not the resource. Yep, so it'd be the action. And then dogs would go where, do you think? Yep, exactly, into params. So the thing is, though, we didn't actually have any params, right? If I go to contacts, there are no params left over. So we need to be careful because it could be empty. So what we'll do is we'll do an isSet, and we'll say, hey, do you have parts 3 set? And we'll ask it as a question. This expression is known as a ternary. I'm pretty sure I covered it in lesson 1, but it is known as a ternary. So if parts 3 is set, then what I want to do is take off the remainder of the array and provide it back as params. So to do that, I'm going to use a function called arraySlice. What arraySlice does is it starts at an index and cuts off a length of the array and returns it. So we're going to take parts as the array. We're going to start at index 3. And we're going to return the remainder of the array by counting it. So arraySlice, the first argument is the array you want to slice. The index, or offset as they call it, that you want to start at. And then the number of items in the array you want to cut off. So we want to cut off the remaining number of items, right? So if we do count parts, it will return the total number, and we will cut off all the way to that index number. Otherwise, we want to return back an empty array. So if this fails and returns back nothing, if this fails, then we will return an empty array. If this passes, though, if this is equal to true, we'll do this really cool little array slice. So let's take a look at what params will be. So if I refresh, it's empty, right? If I add in another piece, it's still empty, and that's because show would be an action. However, if I pass in another piece, I now have the last value as a parameter. So 1, 2, 3. Cool, eh? Cool beans. So just a quick recap. Root represents the root path of our whole directory. We're never going to use this, but we're just going to store it anyways. Resource, this is the data that you're trying to access. That's what resource is for. Action is the thing you want to do. By default, it will always be indexed, but you can pass a different action. And then the remaining parts will always be the params. Why does PHP have so many exaggerated names for codes such as explode and die? I don't know. Explode's kind of interesting because in JavaScript it's split. So if you want to take a string and convert it into an array, you call split. But PHP doesn't just have explode. If I have an array and I want to turn it into a string, how do you think I do that? What do you think the command would be to take an array and turn it into a string? So the opposite of what explode does. Yeah, exactly. It's implode. And you know what's even funnier about implode is the arguments go in reverse. So explode looks for the delimiter and then the array, or then the string. And implode looks for the array and then the delimiter. So it's in reverse. One of the reasons why people kind of hype on PHP a little bit. Just because there's a lot of inconsistencies like that. Alright, so we now have our parts. We've taken this wonderful path and we've broken it into some cool pieces. The next thing we need to know is, how was this actually delivered to us? What HTTP method did they use to make the request? Did they make a GET request? Are they just looking for data? Or are they wanting to manipulate data, which means they would be sending a POST request? Well, once again, our global associative array server comes to our rescue and provides us that information under request method. Yep. Request method will tell us the method that the user has used or that the client used in order to get here. So as you can see, it was a GET method. The GET method is how they were able to access this page. They used a GET method, which is generally the method that will be used because that's the default one. The only time that this will change to POST is when they submit a form. There are a bunch of different methods that are available for request methods. There's get, post, put, delete, head, and patch, but you never see put, delete, head, and patch unless you're using a framework, because generally they have to be wrapped, because most browsers only support get and post. Don't worry, we're almost done and then we'll take a break. So, step 5. The logic below first attempts to see if a resource has been defined, and if it has, then it executes some code. So we don't care if the person's just accessing the API endpoint. We don't care. We'll likely just blow up. That's likely what's going to happen. We'll blow up, and that'll be the end of it, which is the scenario in this scenario, right? Because we have an undefined offset. But if they pass a resource like contacts, we want to be able to execute something. So we're going to write a small condition here that says if resource. If this value does not exist, then we won't do anything, right? If the value is empty, things blow up. We should fix this error. There shouldn't be an error here, but we'll leave it for now. So the first thing we're going to do is dynamically pull the functions based on the resource they're accessing. And you might be like, well, how are you going to do that? So the way we're going to do that, if you notice, under the contacts folder, which is the name of the resource they're attempting to access, I have this file called controller.php. So what I'm going to do is, if there's a resource, I'm going to require once, remember that from last week, right? The resource. And I'm going to dynamically access the resource by typing in resource here, slash, so now this would be contacts, right? Contacts slash controller.php. Isn't that smart? And now we're loading all the functions that are listed under the controller.php page. The next step is to create a switch listening to the action. So the action we defined up here, right? Action is parts 2. Action can be empty though, right? It can be an empty string, so don't forget that. But we're going to create a switch that listens to that action. And really the only thing we're caring about is the request method that they used to request that particular thing. So what we're going to do is say case show, right? So if the action they passed is show, then we'll execute. And I bet you didn't know you could do this. Case search. So notice I don't have a break tag. So essentially what will happen is this basically means if the action is show or search, and we'll put a break tag in here, then it will execute what's ever between these lines and the break tag. Then we're going to have case create, case update, case delete, and then those will do something different. And then the last one that we're going to have is the default, and it will break. So that's kind of an interesting case statement. I'm not sure if you've seen this before, but the way switch statements work is it will keep executing as long as the cases are true and we're not breaking or returning. So because this case is true and we're not returning, then it will go to the next one. If this case is true and we're not returning, or even if it's not true, it doesn't matter. It will execute the code that's in here. And the code we want to execute is if the request method does not, whoops, helps if we put it in the thing, does not equal get. So if the request method is not a get request, then we're going to return a response. Remember that function we wrote up there? 404, which means not found. And we're going to do it in this nice JSON looking way. So basically, if they've tried to do a search or a show and they didn't use the HTTP request method get, then we're going to return a 404 and say, nope, sorry, you're not allowed to do that. So this would mean that they've tried to do this using post, right? And then with the create, update, and delete, same scenario, only we're reversing the request method. So if it doesn't equal post, then we're going to return that response of 404 with a status message pointing to not found. Uh-oh. Right? And then in the default, this one's a little bit different only because, yes, we want to make sure that we're still looking for the specific request method, and in this scenario it will be get that we want it to be, but we also need to set our action. Essentially what our default method is going to be is index, right? So show will return one contact that is specific based on an ID they give us. Search will return back a list of contacts based on a term. Create will create one contact. Update will update one contact. Delete will delete one contact, but they all work on post. Index will return all of the contacts. So the way we do that is we're going to say if $request method does not equal get, then that same scenario, return the response of a 404 with the status message. Helps if I can write. Status message not found. Otherwise, if we make it out of there, we're going to set our action to index. So walk through this again. We're looking at the action that will come from here. So if I type in /show, I'm now in this breakpoint, right? And I'm checking to see if it's a 404 or not. If I want to do a create, this will actually throw an error. If I type in create, I get status message not found because I'm not posting it. Because I'm not posting it, it sends back that error. If I access contacts, it should work because I'm doing it by the default way. Only now I've set a variable to action. So the action is important. We need the action in order to trigger which particular function call we want to do from our controller. So that's what we're essentially doing. These actions are actually the function name that we're going to define in our controller. And then we're going to dynamically call that function, which is kind of tricky, but you can do this in every programming language. You just need to know the function call to do it in. So with PHP, it's call user func array. And that takes two arguments. One is a string with the function name that you want to call. So we want to call the action. And then the second one is a list of parameters as an array. So we're going to pass it params. And this will blow up for sure. Yeah. Because it says there's no function index found. That's because we haven't actually defined it in the controller yet. So the first controller we're actually going to create tonight is called Chuckisms. That'll be the first one that we'll do. So Manjinder, this particular thing, this function will call a function by a string. So if I was to call user func array and pass it index, it will look for a function that we have registered called index, and it will execute it, and then it will pass it that empty array. So just before we go on our break, if we go to Chuckisms, you'll see a controller there. Go ahead and open up that controller. And we're going to create a very basic controller action here. The way we can create our controller action is by first giving it the name, and we have one of 6 names that we can give it. It can be index, show, search, create, update, or delete only. But it has to be one of those 6. The reason being is that when the index calls this and it calls index, we need to make sure that function exists under our controller. this is going to be kind of neat. It's $response equals file get contents, which reaches out across the internet and accesses an endpoint for us, an external endpoint. This is the external endpoint. So go ahead and copy that and then paste it in there. So that's going to get the contents for us. And then we're going to return a response. The response will be a 200, like a 200 status code. And we're going to need to decode the response. So there's the whole function. Once you have that typed out, change contacts to Chuckisms, just like it's named in the file folder there, and hit enter, and it should return back some sort of thing. If you look under value, you'll see the joke. Sometimes they're not very nice. Sometimes they're kind of mean. Like, some of these don't make sense. Most folks play badminton with a racket and a birdie. Chuck Norris plays badminton with a boat oar and a dead chicken. Another way to explain a Chuck Norris roundhouse kick to the face is dematerializing. There's tons of these things, by the way. And once you have that in there, it should, if I'm correct, the client should start now loading that as well. Yep. So under the client, you will see a new Chuckism every time you refresh the page. See? You'll get a new Chuckism in the client. Cool? All right, let's take a 10-minute break to 8:30, and then we will crush the contacts controller and call it a night. Sound like a plan? All right, let's take a 10-minute break. All right, and we're back. Okay, so if we look at the current state of our client, basically it's okay. We've got the Chuck Norris little bit of API showing up. However, we do have an issue where this is still saying invalid argument, blah, blah, blah. And the reason is because our our index for our client is attempting to get the rows right here, but it can't because we haven't actually filled out that information in our contacts controller. In fact, our contacts controller is missing most of the functionality it needs. So we should write that functionality. Now, I did write a create function for us, and I wrote the update function, and I wrote the delete function because it's the same code. If you look at it, it's the same code we wrote last week anyways, right? So there's no reason to change it out. It's still doing all the same validation and sanitization and normalization that we do. So it's basically the same stuff. So we're not going to write it again because we are going to write it next week anyways when we do our authentication stuff. So what we need now is we need the index, show, and search that we were talking about inside our index file, right? We have show, search, and then this index. Index is super simple. All it is going to retrieve the current contents of our contacts database and then display that. That's basically all it's going to do. So let's write that one first. Do we have a contacts database? Did we create one in our class? Because I forget. Does that ring a bell? I guess we'll find out. If we don't have it, then I'll give you the SQL to create it. But I thought we did have it. Anyways, the first thing we're going to do is write a nice function. We're going to call it index, like so. We haven't talked a lot about error handling in this class, but error handling is something that we should consider. However, I think I asked you guys a long time ago whether or not you've used try-catch before, and you did. So try-catch is the same regardless of what language you're working in. It works the same way. We're going to write a try-catch statement. And the exception that we're going to catch is, this is where it differs from other languages. You name the exception type. So a general exception in PHP is just called exception. And then you store whatever it returns into a variable. So we're going to pass it into a variable called error. If an exception occurs, we're just going to return that response that we were talking about before. It'll be a 404. We're going to give it a status message. You can't hear me? Can anybody else hear me? Or can nobody hear me? I've been talking for a long time before you guys tell me I'm muted. We're creating the index function right now. I'm writing a try-catch statement here. The try-catch looks the same as in any other programming language, except for the catch, you give it the exception type. So this means general exception. It's basically a base class for all exceptions. And then the variable to store the error in. So we're just going to give it error. To access that variable, first we're just going to create, this is going to be weird because it's going to go off the screen a bit. Issue retrieving results. And then a second thing here called errors. And that's going to take its own array. And in there we'll pass in error get message variable. I'm going to copy and paste that just because it's kind of an odd one to write. There you go. So that will handle our error if we get any errors. Otherwise, we're just doing a basic SQL. So we're going to create SQL. We're going to say select star from contacts. That explains why you guys weren't responding when I was asking you, did we have a contacts data, like a contacts table? Did we create one in this class? I don't remember. I know I have a contacts table. You guys don't remember either? I guess we'll find out in a few minutes when we go to access it and it blows up. You guys can hear me now, right? Like this is actually working now? Okay, good. Because you're not responding. Alright. I've hit you guys with a knowledge stick tonight. Here's how we're going to write to our database. So the DBO will actually return that database connection. Then we can pipe a thin arrow called query $SQL and call another one and get fetch all and access the PDO fetch a sock. So what that will do is it will return all of our select star contacts as an associative array. So let me give you that. That's going under contacts, controller.php, paste. There you go. So let's see if that works. So if I go to here and I change this from Chuckisms to contacts, I get none. Should be definitely executing. That's the index. Maybe I don't have anything in my database. I bet you that's the issue, that I don't have anything in the database. If it's the case though and it's still working, it should have fixed the client. Nope, still have an issue. Valid argument supplied for each. Let's load up my Sql Workbench and see if I actually have the contacts database or table in there. Will open when I click you. So according to this, I have a contacts table. Don't know if there's any data in it. It's null though, it's empty right now. Okay, so that's not too terribly bad. But the index page for the client shouldn't be blowing up. Invalid arguments supplied for 4 each on line 174. So it's likely rows. And rows is coming from file get contents base endpoint contacts, which should be returning the response from, not this guy, but from this guy. So fetch all ASOC should return. Let's see what's in it. Oh, we're not returning anything. That's the problem. Duh. Let's return a response. It's a 200. And what am I looking for? Just the, I guess just the result. I think that's all we want, is just the result. Yep, there's an empty array. That's what the issue was. And the error should go away. The error went away. Yay, us! We did it. So I'll paste this because the first one was wrong. So that's contactsindex.php, and this is what we're working with here. So again, just to walk through what's happening, when we refresh, basically what happens is we call file get contents, which reaches out to the internet and looks for this API endpoint, right? Just like we did with Chuckisms. It just so happens that this actually points to this index file, right? So we hit this index file, we take that path that the user's looking for, this /contacts, and we break it apart and we figure out which part of that is the resource. Well, the resource is contacts. Then we say if resource, go through here and see if it matches any of these things. It doesn't match any of them, but it does match our index. So what it's going to do is call the index action from the controller, which is this thing here, the controller it loaded, which is the contacts controller. So this one. There's our index function. It fires off this function. Kind of neat, eh? Super simple. I mean, we can make it way more complex, but that is super simple. Does what it needs to do. All right, you ready for show? We might as well write show, but we really can't do anything with it anyways because we're going to wind up with the same issue because we don't actually have any created details. Why don't we create something? That makes more sense. Let's go to the client. The create should work. So go ahead and fill out the client with some information, right? So we'll do McKinnon, 42. I don't know if that actually worked because I can't see. There we go. Yeah, it's 42. Okay. And then my email address. And then my personal page. This is actually real. There we go. And I'm going to create. Yes, I'm sure. Didn't like that at all. It tried to send it to contacts create, but it failed to open a stream. The request failed. Not found on index on line 56 of the client. So I think what may have happened there, I think when I was putting this together, I got witty. And I wrote steps in here, which I probably shouldn't have done. Did I change the form so it's not posting? No, it's posting. So the action is to itself. And then it said line 56 is the problem. Base endpoint contacts action. So the action should be create. So it should be pointing to localhost comp 1006 lesson 7 API contacts create. I don't see any problem with that path. Unless for some reason the path isn't there. So when it says it failed to open the stream, it means that when it went to make the request to the API endpoint, for whatever reason, the API endpoint didn't respond. Yep, it doesn't like it. Huh. I know I had it working before. So this sets up our options for it. And then we pass the options with the context in here. File get contents, base endpoint. Let's just make sure our endpoint is correct. I hate it when things work and then they just stop working. And I hope it's not anything weird that's causing it. Okay, let's just try ASDFs. Actually, we don't even need a thing because it's optional. Interesting. Okay, I'm not sure why it glitched the first time. The var dump literally does nothing, so I don't know what would change how it works. Yeah, I got nothing. Get files contacts, failed to open stream. Yeah, that's literally the same error that I was getting. Sorry, that's when you create though, right? Is that when you create or when you're just trying to read that data? Yeah, I don't know, Minjinder. The only thing I can think of is that your address is wrong. Failed to open stream. Okay, 1 second. Let's just fix the create and see if it works. So that's not even working. That's supposed to actually load up these fields. And delete should load up these fields too, so that you can actually delete them. I think somehow some things got messed up. Alright, so warning file get contents, HTTP localhost conf lesson 7. Alright, let's wrap up this lesson first before we start getting into troubleshooting, because I have a funny feeling we're going to be troubleshooting for the majority of the night. Okay, so for the contacts page, let's just write the last two actions, and then I'll go through and do troubleshooting with you guys. So I'll write the function show, so at least you can show something as well. So it takes an ID as an argument this time. So when you actually pass in an ID, so you give it show, and we'll give it 1, for example, it will actually pull back the whatchamacallit, the argument for it. But this one would be probably 2 or 3. There. That's weird. Expects parameter 1 to be a valid callback. So the reason why it's saying that is because show is not currently implemented. So there we go. So for show, we need to write the SQL. And we'll add select star from contacts where ID equals :ID. Okay, and then we will bind it. So statement will equal DBO, and we have to prepare this statement. Hopefully you remember this from when we did the SQL with PDO last time. Then we have to bind our parameter. So we're going to bind our param. It takes $ID, $ID, PDO, param int, which filters it to be an integer. Then we're going to execute it. And then we're going to store the result. Lots of moving parts here. And then we're going to return that as a response. So actually we have kind of a weird scenario here where it doesn't return what it's expecting because PHP does something bizarre with empty associative arrays. It returns them as an actual array, and that's not the thing. We need to return it as an empty object. So we're just going to add that return there. And then response 202 and $results. Actually, that's a 200. I don't know why I wrote 202. So this whole thing should be encased in a try catch. We're just running out of time. So if I refresh, it's showing that it couldn't find that particular ID. I think it might be like 5, maybe 6. I don't know what it is. What are you? 12. There it goes. And it's working. So that's the show statement. The show will actually pull a single record from our database. Shouldn't seem new. Should be fairly familiar from when we covered PDO actions. And then the last one I want to cover is search. Actually, you know what? I don't even have search implemented on the front, so we'll just leave search for now. We have show, and we'll just get everything else working. So now that show is implemented, I think the client will work now. Yeah, it works now. That's what the issue was. It was missing the show operation. And if you click delete, you have to click the button, click OK. It deletes that entry. All right, so that's it, basically. That's everything for now. Very complex subject. I definitely recommend looking over the code. What I also recommend doing, and I don't know if you do this, but I used to do it when I was in school, I would trace the code that we went through and basically draw a diagram mapping it out so I understood what was calling what and what was happening with what variable and when. That's the best thing you can do for better understanding code. What I will tell you, when you go out in the industry, you will find often that people will not handhold you through your code. They will expect you to be able to trace code. So it is definitely a good idea to learn to trace code. So if you're having difficulty following how we're getting from the index file underneath the API into these controllers, then you definitely need to be tracing that code. Okay? Yes, I certainly can do what you were asking, Gerline. 1 second. There, that code is pushed to GitHub. I don't know if you have access to it already. Is it this one? Lesson 7? I think it is, right? Yeah. Yeah, it's a good idea, Marcos, especially if you print it out, because then you can write little notes on where it's actually located. All right, so I know a bunch of you have errors, so I'm going to stop recording here.